Welcome to BKW Physics. I'm Mr. McConnelly, and today we're going to go through a problem which is called an Fnet problem. So Cheyenne, can you read that for us?
You are driving a 2,500 kilogram car at a constant speed of 14 meters per second along an icy but straight level road. As you approach an intersection, the traffic light turns red. You slam on the brakes. Your wheels lock, the tires begin skidding, and the car slides to a halt in a distance of 25 meters. What is the coefficient of kinetic friction between your tires and the icy road?
Okay. From what you read me, this is what I heard. I heard that the mass is 2,500. You're going initially at 14 meters per second. You stop, so your final velocity is 0. It takes you 25 meters, and they want to know the coefficient of friction. This sounds confusing, sounds difficult. Well, where do we start? We always start with a good picture. So here's my pickup truck here. I usually draw a pickup truck so you can tell which way they're going. And on my pickup truck, I'm going to draw all the forces acting on this pickup truck. So, in the downward direction, everybody, we have force of gravity. Opposing that, in the upward direction, we have normal force. I didn't hear as many people. Now, if the truck's going this way, but slowing down, what direction is the force that's slowing it down? The opposite. I see everyone's fingers pointing this way, and that's called the force of friction. Is there anything actually pulling the truck forward at this point once you let off the accelerator? No. There's not a forward force. I will ask you this on a test question to make sure you understand this concept. This is a really important concept. Once you let off the gas, there's nothing pulling you forward. No force is pulling you forward. Lock that in. All right, so next step. I say to myself, okay, I got to set up a net force equation. So I say the F net is equal to all the forces on my diagram. So Fg and Fn and Ff. Now what's really important here is that the Fn and the Fg actually cancel each other out because they're equal and opposite. So I can immediately just get rid of them. So my net force in this situation is equal to my force of friction. Oh, well, that's interesting. And it seems like the problem's going to be pretty easy, but there's a couple like unforeseen things coming here. So the next thing I say is, okay, I know that F net is mass times acceleration. We learned that previously. I know that FF is mu times Fn. Here's where I see my first problem. I don't have the acceleration. And when I don't have the acceleration, it's going to require that I do a little side problem. So, here I go. Use a different color to enhance learning. I come over here and I got to figure out the acceleration. So, what was I given? I got VFs and VIs and Ds, and my mind's turning, and I come up with the old equation from a few weeks ago. That VF squared. Is that what you're going to say, Chase? Yeah. Nice job. VF squared equals VI squared plus 2AD. I'm looking for, no, I'm not looking for D, I'm looking for A. I lost track of what I was doing there. So I'm looking for A. VF squared minus VI squared over 2D. That's just rearranging. Let's plug in some stuff here. So we got initial velocity of 0, we got our final velocity of 0, we got initial velocity of 14. Remember to square that. 25 meters. Okay, bottom line is, when all is said and done, you hand it in, plug it into your handy dandy calculator, you are going to get a negative 3.95 meters per second squared. Good. Now I did all that work just so I could continue on my F net back over here. So back to the black marker, we got a mass of 2,500. We got an acceleration of negative 3.95 meters per second squared. That's going to equal mu, which remember, the mu is what we were really ultimately looking for. And one more little tricky step here. Remember, Fn is the same as Fg, and Fg is mass times gravity. So when I plug in right here, I'm going to plug in mass times gravity. Everyone kind of with me on that little thought process? So the mass was 2,500 kilograms, and gravity is negative 9.81 meters per second squared. Well, the short punchline of it is when you solve on your calculator, it's going to give you 0.4. So the mu value for this situation, and the mu value is a relative number, meaning how sticky the two surfaces are, is going to turn out to be 0.4. Chase? No. Okay. That's it for today. Physics.